Hello everyone, welcome to the Mathematics in my channel. So after a long time, okay, it's a little bit difficult to upload the video with my work, but anyway, I will try to my best to upload videos. Okay, here in this video we have an interesting integral from 0 to 1 arctan of x minus x to the n over 1 plus x to the n plus 1 dx. Okay, at first glance, we know here we can use arctan formula. We know arctan of x minus arctan of y is equal to arctan of x minus y over 1 plus x y. So let's write our integral. I is equal to integral from 0 to 1. Now using this formula we have arctan of x dx minus integral from 0 to 1 arctan of x to the n dx. Okay, let's take these two integrals, this one I1 and this one I2. So we have to evaluate two different integrals here. I1, so I1, we know I1 integral from 0 to 1 arctan of x dx. This is a simple integral. We all know this is we can evaluate by using integration by parts. So here we have x times arctan of x limit from 0 to 1, then minus integral from 0 to 1. Now here we have x, then derivative of arctan of x, we know 1 over 1 plus x square dx. Okay, then here if we apply limit here, arctan of 1 we know pi over 4, so we have pi over 4. Then here minus. Now how to evaluate this integral? Okay, here we have in the denominator 1 plus x square. So if we differentiate the denominator, we have 2 times x. So I'm going to write here 2. So we should write here 1 half. Then here we have this 1 half. And now we know derivative of the denominator replacing the numerator. So we have natural log of 1 plus x square limit from 0 to 1. So we have pi over 4 minus 1 half. Now if we apply limit, we have here natural log of 2. Okay, this is the answer for I1. So I1 we have 5 over 4 minus 1 half natural log of 2. Okay, then let's go to this integral I2. So I2 is equal to integral from 0 to 1 arctan of x to the n dx. So this integral also we know integration by parts. Let's evaluate. So here x times arctan of x to the n limit 0 to 1 minus then integral from 0 to 1. Now here we know x, then integration of arctan of x to the n, so 1 plus x to the 2n. Then according to chain rule of differentiation, we know derivative of x to the n, we have n times x to the n minus 1 and here dx. Well, now again if we apply limit, here we have pi over 4, here minus. Now here we have n, so outside of the integral sign we have n. Integral from 0 to 1. Now we can simplify this one. Here x times x to the n minus 1 means x to the n over 1 plus x to the 2 times n dx. Okay, now here we have beautiful integral, but this one I evaluated in my channel I think 1 year before. So I will add the link of the solution of this integral in description, and also make a card. So let's take the general case of this integral. So I evaluated this one, integral from 0 to 1 x to the m over 1 plus x to the n dx. The answer we got 1 over 2n times here digamma of m plus n plus 1 over 2 times n minus digamma of m plus 1 over 2 times n. Okay, so we know now instead of this integral, now we have j. So here n, and here so we have m. So we know instead of m we have n, and instead of n we have 2 times n. So we can write now j is equal to 1 over here 2 times n. So n we know 2 times n, so 1 over 4 times n, and here parenthesis digamma of now m plus n plus 1, so n plus 2n plus 1, so we have 3n plus 1 over 2 times n we know 2 times n, so we have 4 times n. Then here minus digamma of n plus 1 over 4 times n. Okay, then we have this is j. So here I2, so we have I2 5 over 4 minus, so we have I2 is equal to pi over 4 minus now here we have n, so n times j we know now 1 over 4 times n digamma of 3n plus 1 over 4 times n minus digamma of n plus 1 over 4 times n. Okay, we know this n get cancelled, and here we have I2. So this is the I2, and now let's take our integral I. We have I is equal to I1 minus I2. I1 we evaluated in the beginning, so here I1, so I1 5 over 4 minus 1 half natural log of 2, so 5 over 4 minus 1 half natural log of 2, here 1 half natural log of 2, then minus I2, so minus here I2, so 5 over 4, then plus we have 1 over 4, and here digamma of 3n plus 1 over 4 times n minus digamma of n plus 1 over 4 times n. Well, then we know this 5 over 4 get cancelled, and we can take 1 over 4 as a common factor. So we have digamma of 3n plus 1 over 4 times n minus digamma of n plus 1 over 4 times n minus here natural log of 2. So if you multiply both numerator and denominator by 2, here natural log of 2 is cos, so natural log of 4. Okay, this is the answer for this nice integral. If you like this type of videos, please subscribe my channel. Thank you for watching.